third law. Just a quick review. What is a force? Well, a force is simply a push or a pull. Okay? So forces are push, pull. Okay? Net force, okay? Net force is when you have objects that are acting in the same direction, and in that case you would take those net forces and add them together. If you had objects that were working against each other, for example, okay, opposite forces here, you would end up subtracting those forces, and then the resulting movement would be in the direction of the larger. So let's say that the red force here is larger. Okay. The resulting movement would then be in the direction the red force is acting. So, just a couple of quick questions here for you. Are there any forces acting on you? Well, yes. Hopefully you said gravity. Okay. Now, if you're sitting, listening to this, okay, you're sitting, you got your little headphones on, or maybe you're listening on a computer. Gravity is pulling you down. But if gravity is pulling you down, why are you not moving down in the direction gravity is pulling you? Well, the simple answer is that chair is pushing you up. Okay? And so, the desk you may be sitting at, are the forces acting on it? Yes. Hopefully the same thing you're answering. The floor is pushing up on the table while gravity is pushing down on it. And the floor, okay, let's say that there's the floor. Well, the ground beneath that floor is pushing it up, whereas gravity is pushing it down, or pulling it down. So the same thing applies in each of these situations. You have what's called a normal force, or the force of whatever's below you forcing you up, while gravity continues to pull you down. Newton's third law of action-reaction simply states that for every action, there's an equal and opposite reaction. Okay, so if you look at the example here, if you push on the door pushes back with an equal amount of force. Now, if you push harder than the door pushes on you, then there's acceleration because the net force is not zero. As long as we have a net force, there will be movement or acceleration. This example, the person that's pulling on the door is pulling back with an equal amount of force until this person pulls with more force than the door can exert. Once the person pulls with more force than the door, then the door will open. A booster rocket, for example, from the space shuttle, is a good example of Newton's third law. At one end is closed. Okay, it has an igniter which ignites the fuel source, whether it's a solid source or whether it's a gaseous source. And then you have the opening down at the other end. Okay? In the nozzle, gas expands and spreads out. The misconception here is that this gas is what propels the rocket forward. And it's a misconception because there's nothing here for this gas to push against other than other gas. And when that happens, okay, the gases simply move as a fluid, which you don't need to know until maybe high school or college physics, but it moves as a fluid out into the environment. The movement comes from right here. Okay? When the explosions or the ignition happens in the rocket, you actually have force pushing in all directions. Okay? And this force goes out the tail end, creates a low pressure area. Okay? It's low pressure because this gets to leave. It escapes. This is high pressure because this doesn't get to escape. Now, the result is pushing at the tip of this rocket, and the continued pushing actually causes the propulsion. It is what allows the... Okay, so to end up here, we're going to take a look at a couple of examples. In this example, we have a frog jumping, okay? And this frog is exerting a force. Let's say that's a rock. Maybe it's a lily pad, but whatever the case may be. The frog is forcing down on that substance there. Now, it is forcing back with an equal amount of force. Now, because there is force pushing down and force pushing up, that is what allows the frog's movement to continue in that direction. Okay, several forces here. Okay, obviously, in that last one we didn't mention anything about gravity, but gravity is definitely applied. Okay, there's force here between the dog's paw and the skateboard. Okay, the dog's paw is forcing the skateboard towards you, if that dog's coming towards you. Okay, and then that skateboard is pushing on the dog in that direction. And it's similar to how this ground is acting. The ground is acting in that direction. It tries to oppose the motion of that dog, okay, as well as the skateboard. And the dog, okay, the dog is forcing, okay, in that direction. And because of the force in that direction, it allows the skateboard to continue in this direction. Okay, another example. We have a car, okay, and the force of the wheels of this car are pushing in this direction, okay, because they rotate in this direction, therefore that's the resulting force, okay, and because that's the force that each of the drive wheels is pushing on the ground with, the ground is actually pushing in this direction, and that's what allows the direction of the car to be as it is. Alright, well, let's review. We have a car in an example of a crash safety test. And typically what happens is these cars are hooked up to a track and they're launched. Okay? And the same kind of mechanism that launches aircraft from an aircraft carrier is what launches these things. So it's kind of amusing to think about. Anyway, direction is in this way. Okay? And the barrier has its own force and its own mass, and it's going to push back on the car in this direction. Okay, equal and opposite. Now, what's going to happen? Well, I'm pretty sure we've all seen the examples. All this part of the car is going to just collapse in, and that's by design. And the design of that is to help with your safety. So, what will happen is the car's force meets the barrier's force. The back of the car continues in that direction because of inertia, Newton's first law. Okay? And once this part of the car provides enough force for the rear of the car, okay, because now this part of the car is not going to move, but the back part of the car is going to move. Once that matches, then we stop motion. Okay? That is Newton's third law. I hope that helped.